Good evening, everyone, and thank you for joining our virtual college exploration for Missouri students, sponsored by the Missouri Association for College Admission Counseling. We're glad you're here and look forward to an interesting conversation with our friends from Drake University in Des Moines, Iowa. If you do have questions, please remember that your video and your excuse me, and your camera are turned off. So if you're going to ask questions, we ask that you use the Q&A button to type your questions to the presenters at any time over the next 45 minutes. If you would like to sign up for more sessions that are being sponsored by the Missouri Association for College Admission Counseling, you can view the entire schedule, both the ones that happened in the past couple of weeks, plus any of the future sessions for this week or next week on our website, moacac.org. Please know that there will be recordings available of both this session and all previous and future sessions, and those will also all be at our website, available for viewing at moacac.org. And with that, Megan, I'm going to turn it over to you and let you introduce everything about Drake to our students tonight.
Great. Thank you so much. Hi, everybody. Thank you for joining us this evening for a presentation on computer science, artificial intelligence, and data analytics. My name is Megan Rush, and I am an admission counselor here at Drake in Des Moines, Iowa. I cover the St. Louis area, as well as the Nashville area and the southern United States. Most of you on today are probably from the Missouri area, but for those that are from out of state, welcome. You have an admission counselor as well, and that's something that I can help you reference. Otherwise, a quick Google search will do that too. We have two very great professors on tonight, Tim Ernest and Chris Porter, and they are excited to share with you some information about those programs at Drake. So definitely, we're in for a fun 45 minutes. I will turn it over to them while they have a presentation to give, and they'll introduce themselves, but welcome everybody.
All right, thank you, Megan. Yeah, my name is Tim Ernest. I'm a professor of computer science here at Drake University. Chris,
hi, I'm Chris.
Yourself.
I didn't know that my name would be in this order on the slide, so I'm ready to roll. I'm a professor in the Department of Math and Computer Science. I'm the director of Drake's new AI program, which is about 6 weeks old, so it's pretty exciting.
Great. So the goal here is to kind of tell you about sort of uniquely Drake experiences and opportunities for students studying math, computer science, and data analytics. Your questions are probably the most important part about this presentation. So if you have any questions, we would love to kind of hear and answer them in real time. So please don't hesitate to use that Q&A button to help ask any questions you might have, and we'll do our best at answering them as they come up. So a quick outline of kind of what we had planned to present for you is kind of an overview of the programs, math, computer science, artificial intelligence, and data analytics. We'll talk about opportunities like research and extracurricular experiences and internships and things like that. Again, please don't hesitate to ask any questions. Let's get started. So Drake has about 6 math faculty that teach predominantly math or math education. There they are in their glory. Students who are studying mathematics or pursue mathematics are good at math, of course, right? They've been studying math since kindergarten or so, and really with a collegiate mathematics really kind of prepares them for careers, for patterns of data and analysis, and oftentimes graduate study or in theoretical or applied mathematics. Some of our math graduates will get jobs in tech firms or government agencies like the NSA or insurance or institutions like that. So that's a quick little blurb about mathematics. Computer science, there's 6 of us to teach predominantly computer science. We're actually looking for another 2 professors in computer science as well. So we're continuing to grow in computer science. Of course, computer science is about the study and theory and practice of computing. And this involves lots of programming languages, but also logic and data structures and applications of computing where this gets really fun is with cloud computing and computer graphics and robotics and artificial intelligence and things like that. So opportunities for computer science majors oftentimes will go to software engineering or in a wide variety of industries or on to graduate school. There's a new program that we're in the process of proposing in cybersecurity that we're also going to add to the curriculum. So this involves, elements of cybersecurity kind of meshed with our computer science curriculum. So that's a possibility if you want to combine computer science with cybersecurity at Drake University. And then also data analytics. Quick overview of data analytics is really a mixture between statistical modeling and computer science. So it's a relatively new major that kind of mixes the analytics of statistical modeling and the mathematics behind that with pairing that with computer science. So it includes faculty from both our School of Business as well as the Arts and Sciences College as well. And data analytics and computer science and all these industries actually are really increasing in demand. I pulled these headlines from just a recent search. So they're even post-COVID. This last quote here is really, I think, telling that these jobs in technology are really important, especially in a recession or where things look a little bit bleak. These fields are still looking with really bright futures. So we are in the right business. You are in the right area at this point in time. So this is true of computer science as well, right? Computer science is still a really hot commodity, and the industry still needs a lot more computer scientists than we currently have. I'm going to turn over to Chris right now to talk a little bit about the artificial intelligence major.
Mute myself. There we go. Okay, so we've got this new major, an artificial intelligence that we just developed over the last year. And the plan was for a group of faculty, initially we were kind of commissioned from across the university, so not just in the College of Arts and Sciences, but people from the law school, the School of Education, the business school, all came together to come up with a unique program to study AI, its connections to computer science, obviously, but also its broader implications, kind of trying to situate it in the broader world. And so we created something that we don't think anyone else has. We've got kind of the corner of the market on this, a program that allows students to get technical training, but also very interdisciplinary approach. You get exposure to neuroscience, linguistics, philosophy, psychology, statistics, design. There's just a lot of different things that you can do. You can take business courses to supplement the AI major. So we're really excited about what that looks like. I'm teaching the first course in the program now, and I have never encountered students as enthusiastic about the subject matter. I swear, I've taught a lot of math courses where students are like, what do we need this for? But with AI, they're all like, oh my gosh, I can't believe I was reading the news the other day and I saw this thing. And they're just, you can't push that enthusiasm down. So we're really excited about that program. Like I said, this is just the first semester where we roll it out, and already we're seeing a lot of interest, a lot of growth, and we're really optimistic about what this will offer.
Great. Let's add a couple of things here according to the slides, right? The goal here is to prepare students to be successful, in the areas where machines play an important role. And so we want students who are capable of developing new AI technology, but are also confident in discussing advantages and disadvantages of artificial intelligence, ethical implications, and kind of cutting edge tools, and the philosophical underpinnings. So we're not just talking about the technical ones and zeros of artificial intelligence, but this is also involving what it means to be intelligent and that kind of thing as well. Do you want to talk a little bit about the curriculum, perhaps, Chris, here?
Yeah, so there's a broad range of courses. So the first course that we want students to take is this interdisciplinary course. And I just have been bringing in lots of outside expertise within Drake from across the departments to talk about what they are why they're interested in the topic, and how their courses might feed into the AI major. And then you can go on and take courses in philosophy. We've got courses in linguistics, in literature and AI, courses in the English department, so psychology, neuroscience, as I've said before. I'm in the process of working with the law school to hire a new technology law person, a new hire that will be joint with the law school and the College of Arts and Sciences. I don't know if there's any university that has something like that. We've got some really great candidates that will be teaching this legal and ethical issues in information technology. So there's just a lot of exposure to many, many different things. We know, when we were building the major, we heard from industry partners that they like students to be really good at the technical side, but to be really broad in how they locate that, how they situate that. So that's what you get with the curriculum here.
Great, thanks. So a little bit about the concentration options too. There's different paths that you can take through the AI, the major. And so we'll have a core based of those courses that Chris kind of alluded to, but also you can focus in on a computer science concentration or humanities concentration, or maybe even a business AI concentration. So all of those are different kind of paths that you can take, kind of tailor your education in artificial intelligence. And then, I guess, again, some quick internet searches here really indicate that the future is very, very bright for students with these kinds of skill sets. So that's really exciting. Okay. Another major that Drake University provides, and nothing prevents you from like double majoring in artificial intelligence and computer science, or data analytics and mathematics, or something like that. But I want to talk a little bit about kind of the Drake experiences, and one of those is this kind of unique case studies course that we put onto the data analytics program for a senior year. So the senior year students will take this case studies course, which they basically get into teams of other students that are also majoring in data analytics. But there's a pretty diverse set. They might have some students that are more computer science oriented. There might be some students from the business school that are doing data analytics. And so we put them into a team and have them kind of have a data analytics company of sorts. And then we bring in an industry partner at the beginning of the semester, and they come into the classroom and they kind of dump a big data set on your lap. And then they basically said, okay, here, help us inform some decision that we need to make using the data analytics skills that you've learned throughout the course of your college career so far. And then they leave, right? And then you're with your team are kind of set to use the cloud computing and machine learning and the statistical analysis and all the things that you talked about in order to make a recommendation back to this company. So it's a real world kind of experience set into this data analytics coursework. So one of the examples is one of our industry partners that we used is with Hy-Vee. And so Hy-Vee is this grocery store chain, that's in mostly the Midwest. And so the Hy-Vee came and they said, well, we've got just all this data based off of yogurt, right? And so one of the things that yogurt's got this weird reputation amongst grocers that if you have the wrong price and it's too high, the yogurt kind of sits and spoils. But if the price is too low, then it flies off the shelf. So it's really, really price sensitive. So getting the right price for yogurt is really, really important. And so the question is, what should the price of yogurt be tomorrow? And there's a wide variety of different kinds of stores as well. We've got stores in urban areas, we've got stores in rural areas. We've got, and the other question is like, how does weather affect yogurt sales? How does seasons affect yogurt sales? Is it more popular during different times of the year? And so we can kind of do all that number crunching, bring in the big data and look at all this, all the 273 different stores and, 14 years of yogurt sales and give them a recommendation about what the price of yogurt should be tomorrow. That's the whole kind of gist behind data analytics, is that we use the data-driven approach to help us make decisions going forward. So that's kind of a fun, really useful real-world course we put inside of the data analytics major. Chris, am I missing anything on that? Anything to add?
No, I mean, I feel like there's a lot of opportunities that students have had every semester that this gets run. It's with a different company. I know EMC Insurance has been used that as well. And also that they're setting, we're setting a model here for other departments. So mathematics tried to emulate that with the capstone this last year, where they took a bunch of math. They had 18 math students that were analyzing Mid-American's the Mid-American Energy's trucks to figure out what was the optimal time for replacing trucks based on the kind of routes they're doing, how much wear and tear can you handle before you actually should be replacing these things. So the students were using mathematical modeling to kind of solve some other real world, very concrete problems. So this is something we really pride ourselves in doing, having these kinds of ties to the community, and then farming out for them, like having them bring these questions to us, and then we get, set our students on them. It's very open-ended, figure this out. I think it's great for the students to have this opportunity to really have a kind of learning that simulates what they'll really be doing, right? So it's not that we create a gap between theory and practice and they have to figure out how to bridge that gap, but we allow them in the curriculum to bridge it with these kind of courses.
Yeah, for sure. And then also a lot of times these companies will cherry pick or will actually hire those students directly from this course too. So it's going to be a kind of a mini interview process as well, if these students don't already have careers lined up. Another example of a class that's kind of uniquely Drake is this class that we've run in the past. We call it the app class. So this is a cross-listed course with computer science, journalism and graphic design. It's like a software engineering from the computer science perspective. And again, we kind of get all these students and put them into a small team, and we do this really unrealistic thing as we say, okay, students from computer science, journalism, and graphic design, you're going to be on a team here, and we're going to have you make an app. We're actually going to have you make 3 different apps during the course of a semester. Usually an app life cycle is, several months, 9, 10, 11 months, but we're going to have them kind of these quick little prototypes. So we need to find a bright idea and then develop this app really quickly and then kind of do it again a couple of times during the semester. One of the, and we give them a small little prompt, like you have to use the camera or the GPS or the speaker in some way, shape, or form. So one of the examples of an app that was made relatively recently was this Bulldog Parade app that you kind of see here. The prompt was to use the GPS, and so what they did is, Drake's mascot is a bulldog, and there's bulldog statues all over campus. So as kind of an informal way of getting familiar with campus, you take this app and you kind of go around and try to use the GPS to collect all the bulldog statues on campus. In the process, you learn, kind of where all the buildings are on campus. It's like a pre-Pokemon Go, tour app. Essentially. So that was really, really successful and really, I think, invigorating for the students to kind of come together in a team and put something like that together. Another example of an app that was created was this Bad Day app. The prompt here was to use the microphone in some way, shape, or form. And they said, that this is a bad day app. So if you're having a bad day, instead of you ranting at your roommate or your mom or your dad or whatever, you rant at this app instead, and it actually scores then your rant on a scale from 0 to 10 on how loud it was and how long it was, and if any colorful language was used in there as well. So some kind of fun, creative ways that distinctly Drake. I think that Drake kind of puts this spin on doing some real world kind of projects amongst the curriculum. Examples of students working with faculty. And so this is one of my favorite parts about my job, is when I kind of get to link arms with students and go above and beyond the classroom. So one example of this is I had these 2 students, Joel Bensky and Paxton Johnson, who were both physics and computer science double majors. And they wanted to do some research with me. And so we got this project where we got a bunch of data from actually another colleague who had a bunch of data related to amino acids. And so these little, and we could put those amino acids, and the question was, how can we get those amino acids and put them together into a protein structure? And so what Joel and Paxton did is they wrote an artificial intelligence application to kind of solve that problem for us automatically. Instead of having to do it manually, it would take days to do. They could write this AI program, and it was really successful. They wrote a paper about what they've done, and eventually then published it at a conference, and they went and presented at this conference, which you see a picture of them right here. Another example of this is Meredith Moore, who was a neuroscience and computer science double major, wrote a virtual reality application program to kind of incentivize rehab through gameplay. So she had a relative that had injured her elbow, and instead of kind of doing this rehab process, which gets really tedious, she put a virtual reality device on the wrist, and then they can kind of make a game out of this. And so instead of just kind of rehabbing the wrist over and over and over again, you're now kind of flying a plane and collecting coins and kind of making a game out of the rehab process. Same kind of process. She wrote the application, wrote a paper about it, and it got accepted, and she presented it at a conference. On the more mathematical side of things, Professor Eric Manley and John Gormley did a kind of multicast network coded flow and grid graphs, same process again, above and beyond the classroom, working on this, and then got accepted at a conference and presented at the conference. And it was fun. We piled into a van and drove to Wisconsin, and we all presented at the conference. It was a real nice, gratifying experience for the students who worked really hard above and beyond the classroom. All right, so other examples of kind of ongoing work. The students and I are working on some Twitter analysis. So we can use tweets to, they're completely public, right? So we can write these programs that we gather tweets, and we can kind of tell where in the world we want to gather these tweets. So, there's a presidential election happening tonight, right? So maybe we want to gather all these tweets during this particular hour and a half during the debate, excuse me. And then we can kind of judge those tweets based off of sentiment analysis and kind of see where and how people are feeling about the nature of the debate. And so we can use that. We can use also kind of collect tweets during primary seasons, and then use that to help us predict future elections as well as tweets kind of come in. So we can kind of use Twitter as this really interesting grassroots polling mechanism by writing programs to analyze how positive or negative these tweets happen to be. All right. So, and also in order to kind of encourage students to go above and beyond the classroom, we invite students that want to get involved in what we call these Friday research groups. So any student studying math, computer science, data analytics, artificial intelligence is involved to kind of get involved with these semester-long student-led research groups. And there's lots of different kinds of groups. So we had groups that are doing some mathematical modeling and trying to figure out, use the mathematics behind the hurricane tracking and use some differential equations to help to understand how hurricanes are tracked and predicted. We had some students doing some game development. Maybe I'm going to stop here and let Chris kind of chime in and talk about the game development Friday group.
Yeah, so a couple years ago, I was thinking about the old school Zelda games that I played as a kid, and I realized that Drake's campus, this kind of rectangular shape, was similar to the shape of the Hyrule, this world that when I was young, and I thought, it'd be really cool to build Drake's campus as a Zelda like Super Nintendo game. So I found an engine to do that, and I got a group of students together. And this is actually, the project's been going on for 3 years with students graduating and new ones coming in. The entire campus map has been built. Certain buildings on campus are dungeons with puzzles and playable bulldog character. So this is something that I think Tim is now, it got down to just one student, and now there's a whole new influx of first-year students that are part of it and working with Tim on that. So we're kind of handing it around, and it's just this dynamic growing thing. And really, I mean, if the game becomes a real playable thing, then that's great. But if not, students are just having a great time being creative and working together. And so just has something that you can kind of pass the baton over. The years, it's been really neat to see.
It's true. It's really fun. Students are getting together on Friday afternoons and kind of sharing ideas, and they're making all of these like nuanced games, and it's really, really fun. And also involves some computer programming, but also some drag and drop. We had computer science and music double major that actually created like an 8-bit theme for the game in the past. So that's really kind of fun to collaborate on those levels as well. So that's another example of a Friday afternoon research group that we have available to us too. We have a virtual reality group. Another fun story about this is the virtual reality group had, so there's a AAA baseball team that's located in Des Moines, and they had a STEM festival actually held kind of in the ballpark area. And so the virtual reality group made a specific virtual reality application for the STEM festival that was simulating what it's like to try to hit a 100-mile-per-hour fastball. So you put the VR goggles on and you try to hit the ball. And so that was really, really pretty effective and kind of a fun thing for the students kind of to put together with a baseball theme. And so virtual reality is another Friday afternoon research group. We got a robotics group. What they're trying to do for the robotics group is have this robot kind of meander the hall in our building and possibly serve hors d'oeuvres during a party. And so one of the things they have to do is like put a camera on there and learn, the nuances of the building and make sure that they don't, they use machine learning techniques to make sure that they don't bump into people or to walls. And so that's one of my goals for the robotics group. We talked about the Twitter data mining group already. And so there's also a group that was doing some basketball analytics. So the basketball team was kind of interested in, so I just kind of happened to talk to one of the basketball coaches, and he was saying, it'd be great if we could get some analytics based off of not only what are the most effective 5 players on the floor at once, but what about the most effective 2 players? And should I be playing this player with this player more often or less often? And so some real number crunching, some non-trivial kinds of analysis that could be done here. And so we had a group that was doing some basketball analysis and doing basketball as kind of sports analytics as a Friday afternoon project as well. So that was really great too. Oftentimes prospective students have questions about internships. They can vary a lot. Sometimes they're paid, sometimes they're not paid, sometimes they're during the school year, sometimes they're just during the summer, they're for credit or not for credit. They can start actually during their freshman year as well. And so students find them in a wide variety of different ways. So companies will advertise on Drake's Career Services website. I get emails from time to time about internships, word of mouth, certainly. But here is, we've had students that have gotten internships at big fancy tech companies like Google and Apple and Microsoft and Facebook and IBM and Tesla and places like that. But also here's a list of places where students have gotten internships in technology over the past year or so. So, basically the idea here is that if you want an internship, we can find you an internship. There's lots of companies that are really eager for the quality of students that Drake attracts. So internships are not a problem. If you want to put that as a part of your resume and your educational experience, we can make that happen. In fact, there's this new internship opportunity that we have with a partner at Wellmark Insurance that's located in downtown, where it's only explicitly for first-year students. And so the first-year students that are encouraged to apply, and if you get in this cohort, you get paired on a one-to-one basis with a mentor, an employee at Wellmark. And that first semester, that's your first year, that second semester, basically you meet with that mentor 5 or 6 times during the semester. And the mentor kind of helps you kind of think about where your career goals might be. And the goal here is for you to kind of dovetail your education with, an ultimate employment after you graduate. And so this kind of help you ask the right questions, help with your resume and that kind of thing. And then after that first year, you will get entered into the cohort for the second year, and then you've got kind of you're in the pipeline to get an internship with this Wellmark Insurance Company, which is one of the a really great company to work for in Des Moines. So those are all possibilities for internship opportunities. If you're not in an internship, you might want to be doing some research. If you have kind of a career goal for going on to graduate school, there's opportunities for research as well. Students have gotten internship or research experiences at big fancy research institutions like MIT and Cal Berkeley and these national laboratories. So that's a possibility as well. It's not all work, it's fun too, although I think the work is pretty fun as well. There's social activities. So there's this Association for Computing Machinery has a programming contest. It's this marathon event, 3 students, 5 hours. They basically develop programs to help solve problems. The team with the most solutions wins. But to help students get acquainted with the contest rules, I throw a practice party at my house. And so here's an example of a practice party I've done last year or a few years ago. With kind of just have students then kind of pull into corners of my house, and we do an inter squad programming contest so they get familiar with these rules. And and it's just really kind of building camaraderie amongst the computer science students to have fun. We bring a lot of pizza and have some soda, and then do some programming on the side as well. So we have a lot of fun with that. There's a similar experience to the programming contest, only with math problems as well. There's a Women in Math and Computer Science Club that invites speakers to hold events related to math, computer science, and women. And women's issues with math, computer science. We have students have gotten involved with an hour of code, which invites 5th and 6th grade students to kind of explore computer science and computing. There's a local organization called Pi 515. Its mission is to help refugees and minority students learn technology. And so our students have gone off campus to kind of help serve to that organization. And there's also, math and problem solving groups where sometimes mostly math majors get involved with a faculty mentor to kind of solve and discuss challenging problems. Sometimes they play games. Sometimes they reverse engineer the mathematics related to game shows and things like that. Chris, do you want to talk a little bit about the math lab and tutoring opportunities? I think you're muted again, Chris.
We have a very active math lab. What's that?
You go ahead, you're good.
Okay. Yeah, mute. What does that thing do? We have a very active math lab. A lot of our math majors will get trained to be tutors, and then they'll have that as a job where they'll basically be on call. So we have a pretty advanced scheduling system where students can go through and pick the tutors that they prefer, and then have get set up to work with them. And so we've found this to be a really great opportunity, both for students who need help, but students who want to get better at working alongside their peers, and to, if they have any kind of future in education, give them that kind of opportunity as well. So that has been something that we've seen a lot of growth. And in computer science, we're seeing now new opportunities for students to tutor some of the lower level computer science classes as well. So that's been such a success that we've really have a faculty member who has to dedicate a kind of significant chunk of their year, the time that they would normally be teaching. We give them a couple classes off just to oversee this. And so it's something that we highly prioritize.
Great. Every spring, there's a conference on campus. They call it the Dukers Conference. So any student who's doing any work kind of above and beyond the classroom has an opportunity to showcase that through poster sessions or through through oral talks. At the end of your college career, every student is required to complete a capstone kind of experience. And so you'll get paired with a faculty mentor. Sometimes this is done in small groups as well. And the students work on a project during that last semester, and then presents that during a kind of a show and tell poster session during the last day of the semester as well. We have this new building. It's like 2 years old now, Collier Scripps Hall, which we're just in love with. So here's kind of the blueprint of the Collier Scripps Hall. These big yellow rooms are all state-of-the-art classrooms. There's monitors all around the classrooms. And so it allows us to facilitate kind of small group work, but also kind of, I can lecture at the front of the room, but then I can then break the students, do small groups around these different monitors that exist on campus. Down over here on the outside of the building are all the faculty offices. So if you have any questions, you can certainly contact them. There are these zip spaces kind of in the interior of the building, which are designed for small group work, and lots of different areas for nooks and crannies that students can kind of do some work on inside. And then if they want to, all these professors have open office hours that if you get stuck, you can ask any question that you might want to. So it really facilitates student-faculty interaction. The room here on the lower right here is our VR lab and kind of our research area, so we can kind of play on lots of different kind of toys that we have and fun experiences that we have available here. So we have plenty of space to accommodate kind of a really student-centered, above and beyond the classroom kind of approach. All right, so this is the last slide, and then I'll maybe open up for some questions if we have any. What I really love about Drake University, I think it's a great place to get an undergraduate education. Computer science and technology programs are really booming, and the advantages that I see that Drake provides is small class sizes. We have one-to-one interaction with professors. There are research opportunities if you want to go on to graduate school, but also I think it's a great launching pad for graduate school or for industry as well. A lot of our students, almost nearly all 100% of our students are really successful after they graduate from Drake University. So anything else to add there, Chris?
No, I think you've covered the bases. I'm happy to contribute in the Q&A, so we really invite your questions.
So at this point in time, go ahead. If you'd like to have any questions that you could ask, go ahead and use that Q&A button and chat, type in any questions you might have, and we could answer them that you have. Good. Do you want to take that one, Chris? So
yes.
The question is, out of all the universities, what made you pick Drake?
Okay, yeah, click to answer live. One of the things, I guess it's a good question. I mean, I feel like when we apply for jobs, right, we field the market. And so Drake was an early opportunity I had. And when I came to Drake, one of the things I immediately saw was, for me, how friendly the department was and how I could be free as a faculty member to kind of play to my strengths. So my background is in both mathematics and philosophy. I did a joint PhD in 2 areas. And the mathematics research I do is in theoretical computer science. So it kind of forces me to straddle more than 2 areas. And Drake gave me the chance to draw on all of those, that training. And in particular, now that I'm kind of helping pilot the AI program, I mean, I feel like this is just, perfect fit for me, because I can not only continue to do the technical work that I'm doing, but then delve deeper into topics that I might not have kind of learned otherwise. But then also I'm interacting more with peers and colleagues in computer science. For my AI class tomorrow, I have a neuroscience professor coming, and I'm really excited to learn from him. So I'm just getting a chance to learn. The university is really, it's tight. We all know each other across the university. We're not like siloed in different ways. And so you could really get a holistic education. And that, I think, is, so that's how I would answer the question. Tim, what do you think?
Yeah, so when I came to Drake, I had lots of opportunities. I could have gone, lots of different places, but Drake was the right fit for me because of the size of the school and because of the intentionality between the students and the faculty. And so I really wanted to have, that kind of influence and experience in working with these really bright students that are really teachable. And so Drake was the right fit. They're looking for the computer science professor, and it was really, I think it's been great. So I've been here for 15 years. I'm on the forever plan. So it's been just a wonderful place to work and kind of grow and learn and work with these really bright students. So it's been a good fit for me. The next question here is, do you have any prior experience, computing experience? And what do you like most out of computer science? So I guess the question, I'm going to kind of rephrase the question a little bit, if that's okay. So our computer experience really starts from the ground floor. So if you're a student coming in here and don't have any computing experience and looking into getting into artificial intelligence or computer science or data analytics, this is the right place for you. Our intro class starts at the ground floor. So we're not expecting that you have any computing experience or programming experience coming in. I like to tell my computer science 1 class, if you can think logically and turn on a computer, you have the ability to earn an A in this class, right? So we really start from the ground floor. If you do have some experience, prior experience, we'll start you at the appropriate rung on the ladder. But you don't have to have any prior computing experience in order to come in and major in computer science or artificial intelligence or data analytics. And what do you like most about computer science? I'm going to have you answer that first one, Chris.
I think that, I can think about it from a theoretical point of view, because that's really the kind of research I do, but also from a practical point of view. So on the research level, the ideas are just beautiful and you draw on lots of different areas. So I think about how randomness and computation interact, which requires me to know some probability theory, but also I have to use tools from logic. And so I think that it's really fun to see all these different areas kind of come together. So on a theoretical side, for me, I get just really excited. I really love to just think through different ideas and experiment and have fun. On a practical side, I think it's just really exciting that you have this machine that you're so comfortable working with and doing certain things with, but then all of a sudden, when you write a program and you have it do something where you're like, whoa, like it just executed 10,000 lines of code and faster than I can even think about what's happening, and do some really cool things, or you see, new visualizations appear out of nothing, right? I think there's something very rewarding about taking this machine that you kind of, maybe when you first approach it, you feel like, you're at the mercy of it, but then at some point you get confident and it becomes at the mercy of you. What can you do? Like there's no limits. Like it's just, the way in which everything's presented to you is a very specific thing. But once you get comfortable with like, I'm going to open up the terminal and just mess around, and all of a sudden, you're kind of flying. It's really, I think, pretty exciting. So that would be on the kind of more practical side. I think something that's pretty exciting.
Yeah, I got involved with computer graphics when I was first interested in computer science, and I can't draw myself, but I can write code that can draw really beautiful things. And so that kind of gratification of I can think logically, and I can put these, kind of follow these algorithms, I can write the instructions for these algorithms, and it can create this really wonderful thing, was kind of the hook that got me interested and involved in computer science to begin with. And I just like to learn and explore, and these computers are such wonderful machines that just follow instructions. And so it's really about, as soon as you kind of understand how to think algorithmically, then it's just your imagination can kind of open up, and you can create these really wonderful things. So it's really kind of an exciting time to be involved with computer science, because it's just the kind of, we're worlds at your fingertips if you can think algorithmically and write the code to do it. Other questions? Yeah. So the question here is, due to COVID, how much has classes been affected at Drake? And do you use any specific programs for coding? So COVID has certainly thrown a wrench in the system. And so, but the classes are continuing on at the same kind of level of rigor and expectation. They alter a bit as far as the modality that they're being presented in. Sometimes they're face-to-face, but with masks and social distance. Sometimes they're using Zoom kind of like this. But we've kind of really done a pretty good job, I think, of making the curriculum work and the courses work to adapt as best as we can, but still maintain that high, excellent level of education that you'd get at Drake University. And specific programs for coding, we use a variety of different things, and kind of we use the most appropriate tool for the most appropriate problem. So our intro class is using the programming language Python. I think it's a really good introductory programming language. We use different tools to help us program Python code. We then transition on to Java for the next programming language, which is a really good skill set to have on a resume. For for machine learning and for robotics and for cloud computing. We use for the appropriate tools there as well. So I think that we do use specific programs for coding, but it kind of varies from class to class. And once you learn one or two programming languages, after that, we teach you in such a way that picking up additional programming languages and different tools is really just kind of a different way, a slightly different way of thinking. So once you've learned one or two, then you're really off to the races.
Great questions.
Next question. In your opinion, what do you find the most difficult in coding? The hardest part, I think, can be when there's this misconnect between what you think, what you have, the algorithm you have in your mind, and what the computer is actually executing. And so when things get hard is when you and the computer aren't quite communicating or on the right wavelengths, if you will. And so oftentimes that requires to solve that problem somebody else to kind of help. And so that's where a teamwork really, I think, helps in the computing process. Chris, what do you find most difficult about computing?
I think that there's an issue, there's a challenge with taking the big picture ideas and really having to implement them, right? The devil's in the details. And if you want to go light on the details, then you lose. You have to be correct. You have to be rigorous. It can be, you can slap stuff together, but really writing a good program can be challenging. So I think that's, really focusing on the details can sometimes be, be tough.
If I keep an eye on the clock, I think we're getting close to our time. So maybe you have time for one more quick question.
Tim, if I have questions about the material from this presentation, what should I do?
Hey, that's a good question. How about this? You email us. Right? So take a quick note of this. My information, contact information is here. Chris's information here is here as well. So if you have any questions above and beyond, or if you're thinking, oh, I really wish I would have asked this question or that question, please reach out to us. We're more than happy to answer via email or set up another Zoom chat or however we can be most helpful.
We even take phone calls now. We work with admissions to set these things up. I've spoken with a number of students last year who were interested in the AI program, and all the ones I talked to are in my class right now. So please, if you want to talk to us, we're happy to, get to know you. And I think that helps build a bridge to come into Drake. And those students who built that relationship last year, we were really active recruiting with them. They're kind of hitting the ground running. So that's something that I feel like it's very strategic, and we really highly recommend students to take advantage of that, get to know your professors right away. And, it just makes that transition so much smoother.
Awesome. Well, Tim and Chris, thank you again so much for taking the time on your Tuesday night to present. Students, I hope you learned something new. I learned a couple things new, and I've worked at Drake for 2 years. So any questions, like you said, contact Tim or Chris, admissions related, feel free to reach out to me. My email is just the same as theirs, megan.rush@drake.edu. Thank you everyone for tuning in, and have a wonderful evening. Tim and Chris, thank you again so much. Appreciate it.
Thanks a lot.
Thank you so much for joining us tonight for the MOACAC Virtual College Exploration. Just a reminder, there will be a quick 4-question survey as soon as you close this window, and we would really appreciate it if you would take the time to answer those questions. It helps us in the future with plans for more college exploration series. And if you would like to sign up for more sessions, you can do that at our website, moacac.org, or you can view any previously recorded session, or if down the road you want to watch this session again or any other session, you can certainly do that again at our website, moacac.org. Thanks so much for being here. Folks from Drake, thank you. We really appreciate your time tonight. Have a great evening, everyone, and we hope to see you soon.
Good night. Thank you.
Thank you.
Good night.